Okay, so getting started here, what we're going to go over today is the PQView platform and focusing on what PQView can do for end users and utilities in particular. So this is just a quick, our agenda here. We're going to be going, we have an overview, we'll be going over the components architecture, how we collect data, data analysis, and in between those data analysis examples, we'll sprinkle in some case studies, and then a re-summary of the benefits of the software. Just some background on Electrotek as a company. These are our US office locations. The big bulk of us are based out of the Beverly, Massachusetts area. We also have offices down in Edison, New Jersey, where our sister company, Dranetz, is also located. And we also have some folks down in Knoxville, Tennessee. But we do have offices globally. We have offices located in Europe, South America, and Asia. Just a quick overview of our corporate structure for you global folks. You might know the Ghost and Metrowatt name, but really what I'm trying to show here is that our relationship between Dranetz and Electrotek, we are sister companies under GPT. GPT is based out of the Edison, New Jersey office. And so the Dranetz primarily focuses on hardware, while Electrotek primarily focuses on software solutions. So what is PQView? In a nutshell, PQView is a tool that takes data from disparate data sources and systems, whether those be power quality monitors, relays, fault recorders, SCADA systems, other databases, operations information, and collects all that into a PQView database or potentially multiple PQView databases. But the idea is you get all that data in one spot and you can then start applying the same analysis tools to the data regardless of where it came from, regardless of what the data source was. And you can use the same tools. So as opposed to perhaps if one device requires one vendor's tool and another one another vendor's tool, you might be having to learn how to use two different pieces of software, potentially even 3, 4 pieces of software. One of the advantages of PQView is that once you know how to use the software, if you get another piece of hardware or bring some other data source in, you can still use the same tools and analysis tools that you've become familiar with. So the benefits of PQView, just this is going to be an overview here. We'll definitely be going into how these benefits are more specifics in the presentation here. But just as at a high level, it's a device agnostic data concentrator. What that means is that we're, for the most part, we support open file formats like PQDIF and ComTrade. We're talking to as many devices as we can. We build data handlers. We have built data handlers for multiple different types of devices and hardware manufacturers such as Ion, Saytech, SEL. And as companies or as end users come to us with new devices that they want to integrate into PQView, we definitely will attempt to do that. And for the most part, have not come across any devices that we have not been able to integrate yet, assuming that customer does really want that. So once you have all that, you get that data concentrator, and then we have what we consider to be best-in-class data analysis tools, and which allow you to quickly summarize your system performance. So by looking at your system, say geographically, or highlighting hot points based on thresholds and triggers, but by analyzing the data in PQView, by seeing your system all at once, you're able to find problematic locations inside your power system or your facility, and also just kind of know whether you need to be looking for problems by using your performance and doing benchmarking, which is another benefit of our software. One of the quick things, or one of the very useful things of PQView is the quick identification of whether the event was essentially upstream or downstream. This is very useful for end users in a facility because one of the first things that a facilities manager will usually have to do when there's some sort of disturbance is to find out, okay, do I need to start looking for something smoking inside my facility, or do I need to call up my account manager at the utility to kind of find out, hey, do you guys know what happened? Are we going to get hit again? That type of thing. So knowing that as quick as possible is very useful. And one of the great powers of PQView is that it is extensible. So If there's a feature that PQView doesn't have, of course, we are always more than willing to add that, but just realize that you're not the only person asking for a new feature. So, you kind of get added to the list along with all the other feature requests that people are making. However, if you have like a team of developers in your company, or if you just want to do something one-off, you have the power via our SDKs to integrate with other systems. This also allows you to very easily migrate from one system into PQView, because we can, using the SDKs, you can bring the data out of PQView into other systems. So like if you have existing, a good benefit of this would be like if you guys use something like Tableau, being able to pull the data out into those third-party systems. Using that, the benefits of the data concentrator use, a feature of PQView. As I mentioned before, being able to benchmark your system performance or facility power performance, and that will kind of give you, using those benchmarks, you can use that as indicators of whether or not you have problems in your facility or on your system. And this is really the key thing of PQView, is that by being able to bring data from multiple devices, multiple systems, all these sources, so you're able to turn what is, when it's just sitting there, it's data you need, but as soon as you pull that data together, it starts to tell a story. And that story, and a lot of times, can be actionable information. And that's what you're really trying to do, is what's the point of collecting all this data if you're not going to do anything with it? And that's what PQView helps enable folks to do, is to take all the data they have, bring it together, and start building that into actionable information. And so an example of that would be, if you have all these, you have your operations databases, you have your distribution system models, you have your SCADA system, you bring all that together, and along with your power quality data, with your event data coming in from your devices in the field, and you can do fault location, because you can bring all, by bringing all that data together using the waveform analysis from the event that was captured. You can determine the reactance to the fault using the distribution system model. You can plot where on the model that reactance to fault occurs at. And then just by doing that, and by looking at operations databases, you can narrow down which feeder it was based on which breakers tripped. And on information from the SCADA systems can provide even more details and ways to pinpoint that down. And so before, you just had a bunch of disparate sources of data. Now you have the fault location capability. We do have quite a few users of PQView. Quick, these are partial lists, but just to kind of give you a feel for it, PQView is in use all over both the US and internationally. So one of the benefits of that is that with PQView, you can actually essentially share data with other users. You can just share a PQView database with another company, and you can use that to do even larger benchmarking, like if you wanted to do benchmarking across a industry or across utility, stuff like that using PQView. So PQView has quite a few software components, and I just want to highlight a few of them here because, anyway, these are the ones that we're going to be going into more detail further on in the presentation here. So this is the PQDMS is what provides our data aggregator functionality. This is what's actually communicating with the devices in the field, bringing that data, putting it into the PQView database. And this is also the service that would be sending out notifications and providing real-time data. The PQView admin service is the other service that runs in PQView 4. And the admin service essentially manages all of the user authentication and authorization. So it determines whether or not the person can access that resource. Also, do they have the proper credentials, username and password, or if you're using Active Directory, do they have the right credentials? And then once you've authenticated them, then what is their level of authorization? So can they access this database? Can they access that database? Stuff like that. What devices inside of that database are they able to manage and access? So that's all managed via our admin service. Then we have PQWeb 4, which is a website, and via the PQWeb 4 is our primary portal for viewing data out of PQView, and also for setting up devices and all that. The PQView administrator is a web interface for the admin service, and so this is used for doing other setup and configuration and managing connections to database resources and that type of stuff. And then we'll go into this a bit more in detail a little bit later, but we also have developer tools, as I mentioned before, for our extensibility. So the data sources for PQView, as we mentioned before, we're trying to be device and standard agnostic. So right on the top here, we do support IEEE PQDIF and ComTrade. We also support Modbus for getting data in. We do have custom data handlers for systems, and that's what these are here. We can talk with the electro industries, meters. We can communicate with the iGrid system. So you can actually connect to the iGrid. If you have iGrid iSense system set up, then you can connect to that system and get the data from all of the meters there. PQView, SATEC, Schneider Electric, the ion meters we can communicate with directly via the ion protocol. Lots of different devices. We can also, again, bring in data. Mentioned before, distribution system models, so Cooper SIMDIST, Sine, and Synergy Electric. We support both of those as well. If you're interested in seeing all of our data sources, they're all on our website, pqview.com. So we did get a couple of questions in the chat about what PQView can run on. We do support Windows platforms. It was asking if we could run in Azure. We don't currently have anyone using PQView in Azure, so I can't see any reason why that wouldn't work. And other data protocols are being asked. PQView does not support DMP3, but we are currently working on IEC 61850 implementation. So actually, we'd like to get some interaction here. So we have a quick survey here that's going to be posted in the chat while I continue to answer a few questions here. There we go. Juan just posted the survey in the chat. This is showing how we support different ways of getting file-based formats into PQView. So the example we're showing here is ComTrade and PQDIF. Depending on the type of device, you might need to use vendor supplied download software in order to get the data files out of the devices. Or some of the devices we can actually communicate with directly. So depending on the protocol supported by the device, we can connect to it and transfer those PQDIF or ComTrade files off of the device. There's some cases where this is very straightforward. Others, even if this is kind of what's happening behind the scenes, we might have to set up like a custom data handler for it. Because, for example, this is essentially what we're doing for PQs.
Okay. Hopefully I sound better now. Apologies, the wrong microphone was chosen. Depending on whether you have vendor software or if we're getting the files directly from the meter, or if you have some sort of, manually collecting the files, or if you can get these files somewhere that the PQDMS service can then see it, then PQDMS just directly imports that data into the PQView database. Here, showing the integration with Dranetz DataNodes. With Dranetz devices, we can actually both communicate with them and also do configuration on the Dranetz devices. So PQDMS is actually the software that's used to configure Dranetz devices, setting triggers and what data is going to be collected, all that. This is a nice straightforward setup, just talk directly from the DataNodes to the PQDMS, to the PQView database, and then you can use our analysis tools on it. We talk directly to ion meters via the ion protocol. So again, direct connection to the meters via PQDMS, goes in the database analysis tools. And we have multiples of these data handlers that are available. So this is just kind of illustrating that for ion meters, this is the setup, and it would be similar for SEL or SATEC devices as well. In fact, I think we have one here. I have SATEC here. So if you have an existing ion system and you're not interested in resetting up all the communication infrastructure, or if you are okay, resetting up the communication infrastructure to use PQView moving forward, but it's like, well, I have all this old data that I want to be able to bring into my system. We do have our ion database data handler as well, which allows you to connect directly to ion databases that pull that historical data in or continue to bring it in parallel. So this is one of our most recent data handlers. So, we had a few customers that expressed interest in having a SATEC data handler. So we were able to create that. So this is one of our newer ones. So just illustrating that as there's interest or as new devices come on the market, we can incorporate those. This is showing an example of how the software can kind of work together in a system. So here, this customer actually originally was using Ion Enterprise. They had Power Monitor Expert system set up, and that's how they were bringing in the data, and then they were bringing it in via PQView. And they then actually started having troubles with this system. So we had these two systems running in parallel. I think they've actually since retired the Ion Enterprise system, but for a while they were running them in parallel while they were transitioning over from PQView 4 to talking directly to the meters via PQDMS. And then, but we're also bringing in data from their SCADA systems into Pi. PQView can bring data in from Pi. And using all that way they have operation information that's bringing in there, and then all going into the PQView database. Okay. We got another poll, so and I see that we've been having questions load up in there, so that's why I haven't been answering the questions at FYI, because I thought it makes sense to address those while we're doing a poll, so that if people aren't interested in the question, they can do this. So Juan has already posted that in the chat. So please go and do that, and I will look through the questions here. So the question was asked, are data sources company dependent, proprietary, or using common protocols? So we're both. We're supporting both. Let's see here. Another question that was asked is PQView capable of collecting data directly from devices over 4G/IP? So yes, we do have multiple customers that are using cellular modems in order to get data. So yeah, that would not be an issue. If the data is not in PQDIF format, and then in that case, there's more work on the data handler end. So if the data is already in PQDIF, then that makes our data handler work easier, because it's just a matter of, okay, meter, tell us where the files you have are on the meter, and then we download them. Whereas, let's say it's like CSV type values or something like that. That's something we'd have to bring the data in as text files and then map the data to the proper channels inside of PQView and do all that. So, I mean, it just means it's more work on our end, but PQView will eventually bring it into the same format. That's again the power of PQView is you can use those same analysis tools. Okay, there's a question of where is PQView installed physically. So again, PQView is software components. So saying it's not necessarily installed all in one place. You can install it across multiple different, you have a PQDMS that can be running on the same server as the admin service, but it doesn't have to be. So, and both of these are PQView 4. So I don't quite know how to answer that question. And then the database is, again, it can be on the same server or it can be on another server. We primarily use SQL Server, but we also do support Access. A question about what are the IT implications, firewalls of communicating directly to devices. So yeah, obviously, if we're going to communicate directly with the device, we're going to need to talk to it over whatever port that device, so like, for example, ion meters communicate normally over port 7700. So yeah, you'd need to open or allow communication through your firewall to over port 7700 to that device. And it would be, of course, vary depending on, Dranetz meters are by default port 80. So, okay. And there was also a question, we are going to be talking about fault analysis in this presentation, yes. So this is another offering we have, pqweb.com. The solution here is for customers that are either not interested in setting up their own system, or maybe maybe a smaller utility or a smaller end user who doesn't have the infrastructure for a PQView system. We can host it for them. Of course, this would require allowing us communication with the devices, except for other cloud-based data sources such as iGrid. And what the great thing about this too is that we keep this up to date with the latest version of PQView, so you don't have to worry about updating as we release new versions and all that. That is our hosted solution there. Mentioned the SDKs earlier, so just going to go a little bit more into detail on our SDKs here. So we have our PQWeb SDK, which is meant for web developers. So our different SDKs are primarily just different ways of getting to the data, but all the same data you're getting access to. So if you have web developers that are used to programming via a web RESTful type service, then this would be the SDK that you would want for those web developers. We also have our data layer SDK, which is more for folks that are more used to doing Windows desktop type development, doing applications, and those guys would be doing things like using the SDK. They'd use the data layer SDK, so using programming like C#. And then we have our SQL interface SDK. This was, I mentioned before about Tableau. This is how that integration would be provided. So if you have other third-party tools, or if you just want to be able to write SQL queries against the data. And we also do have an API for the PQDMS that allows you to, tell it to initiate meter polls, stuff like that. The main application that always pops to my mind with this would be, if you had some way of triggering when you want to poll a monitor, then you could use the PQDMS API to do exactly that. So now I'm going to get into some of the examples of PQView's waveform analysis. I'm going to go through this fairly quickly. So this is showing an interactive waveform inside of PQView, inside of PQWeb actually. So just one of the quick analysis we can do from the beginning is, that I think is kind of slick, is what's referred to as remove load and show machine voltage. And what that does is takes the first cycle of the voltage and removes it from that and each subsequent cycle, and does the same thing with the current. And so you can actually see that first cycle is now 0. So it helps you. It's not super useful with this waveform, but let's say there was a fault kind of hiding in there, a small fault, especially if you have like DER, you'd be able to see that by removing the load current. And then, same thing with the voltage, essentially removes the nominal voltage, so you can just see the impact from the voltage disturbance. We can also pull up reactive power as a derived chart. Here we're showing we can do an FFT, and you can actually, again, this is interactive, so you can actually click around and change what the FFT is being analyzed on, and just more details of that FFT. You can also do, here showing symmetrical components being derived from the chart. You can also do phasor charts, showing more symmetrical components from a different chart. And then, so just more chart derivations here. Power factor, delta, so that's change in real power, change in reactive power. THD, total harmonic distortion. You can do filtering, so this is a low pass filter. You can see it removed all the fuzziness out of the waveform, so all the high frequency perturbations are removed. Or if you can do a high pass filter, remove all the low frequency stuff, so you only see the high frequency perturbations. So that's the quick rundown of our waveform analysis. There's a lot more stuff in there. If you're interested, we can get you demo access to our PQ website, so PQWeb4.electrotek.com, so that you can play around with that yourself. So this is an example of fault location, starting off with all events when they're brought in. If you have the fault point add-in module, as the events are brought in, they are categorized, and faults are identified. And so, like as you can see here, it's identified that this was a 3-phase fault. It's a fault type 3 ABC. It also highlights the faulted phases over here in the current. So here 2AB, there single phase fault over here. And then if you click on these links here, especially this one that's a globe, you can actually then view the fault on a map. Again, this is demonstration data and demonstration model. This is not actual event, but if it was, you have these areas that are showing possible locations, and then you can also mark in here what the actual location is once you know it. So we have another poll here for folks requesting access for PQWeb4.electrotek.com. You can do that, but not via the chat here. Let's see. We will have contact information at the end. Asking about functionality of PQDMS. PQDMS it's a polling, so you tell it how often that you want to go and pull data from the devices. And of course, if there's no new data to pull, it just touches it and then disconnects. If there's no data to download, it won't download new data. So this is showing integration at a customer. We have some case studies here essentially. And so here this is showing a fault that occurred on their system. You can see here their operations. So they also have it tied into their operations database. So these are the operations that occurred at that time. So at this customer, they get the feeder fault trips. You get the PQ monitor device captures oscillography. We calculate the reactance to fault. The customer uses that value to then determine where in the model it matches, and then they then show it to their operators on their map that tell them what the type of fault was. Here they're even showing the reactance to fault and where on their model the fault occurred on, so they can then go get their dispatchers out there and get that fault resolved. And then what we're showing here on another case study here. So this is showing a customer was able to identify a piece of equipment that was failing out in the field using PQView. They had a cap breaker and switcher doing a restrike. They went out there and here's an image. They actually found pitting on the arcing horn. Another customer used power quality data to help identify failing tap changers in their system. And believe it or not, this is a failing, not a failed tap changer. When tap changers fail, they tend to fail catastrophically and also tend to take the transformer with them. So one of the key things here is, they use this. They found multiple tap changers that were failing in their system doing this. I don't recall if they were all of a particular vintage or not. If you're interested, attend one of our users group meetings. It's worth noting that, this would have taken the transformer with it likely. And so, you're talking about quite a lot of money saved by finding a tap change. Another case study here, customer showing supposed to be a zero crossing breaker here, or zero crossing switch, and you can actually see they were able to, using PQView, identify that it actually wasn't crossing on the zero, and as you can see, here's the corresponding current inrush as a result of it not crossing on the zero. So it's supposed to be crossing right here, but it's actually, by looking at the current, they could see when it was actually closing. So you can help identify equipment that's not operating properly. This was an interesting one. This customer found an issue using PQView where they had a cap bank that was newly installed, and it was opening and closing. It opened and closed 70 times in 9.4 seconds. So you can actually see that happening over here. This is real. This is a real oscillography that's being shown here. So kind of wild there. So obviously that, again, if that had resulted in the bank failing completely, it could have been quite a loss of money there. Another issue found using PQView was here they had a switcher alignment issue here where the pre-arcing contact wasn't being made. So essentially they, whether these are pre-insertion resistors or inductors, weren't being included during the switching. And so you have on that phase much more pronounced transients as a result of that mitigation not being into the switching there. This is showing a customer where they have a distributed energy resource, solar, and showing the impact of a fault as seen at the substation and at the DER site, which is, I think, pretty slick. But you can see how, you can see that the DER is still feeding into the fault, but a lot less current than the substation is, which is to be expected, especially with solar. Solar doesn't have a lot of short circuit current. But you can use that for, making sure that your protection is set up properly, correlated properly. This is indicating that they had the customer said they had a incipient PT failure that was found via PQView. That looks like a PT that already failed to me, so I'm not entirely sure. Or maybe it failed, and here they're just showing that if they were paying attention, they would have caught it before it failed on them. Here, they were showing a loose fuse at a customer's. I think this might have actually been at a service entrance. But yeah, so this was resulting in bad data there. And similarly here, using this, they had a chattering relay, and by looking at the current and seeing that there wasn't anything actually happening as a result of the voltage disturbance, that it was likely not actually on the power system, but just on this relay here. And here, they're showing notching at the zero crossing, perturbations at the voltage peak, the fact that it's only on phase A, which is, so phase A is the only one that's arcing, and then here again, no corresponding response on the current channel. Here, just showing harmonic resonance, which can be very, very bad if left unmitigated. So here, you can see we do have some harmonic resonance to start off with. Something gets switched on, and it looks like even more resonance results at the end here. So using PQView, you could analyze this, see what the frequency is, and help pinpoint what on your system is causing this, and also what harmonic that resonance is occurring at, so that you can try and move your harmonic point by altering the capacitance and inductance in your system. Yeah, speaking of fast Fourier transform, here using the FFT, you can determine the switching frequency of the transient here, primarily 7th order. So that was the bulk of the case studies. So yeah, customers have shown us how PQView is useful for them. We do have one last survey here. Yeah, it looks like Juan has already put that in the chat. We're asking for copies of the presentation. I know we're planning on making the video available. As far as actual copies of the presentation, we'll have to get back to you guys on that. Okay. There's some questions about the filtering and frequency range. If you're curious about that, I'd recommend getting a demo access to the system and play around with it yourself. I don't think we even have any limits on it. Here, this is showing a magnitude duration plot. Most folks are probably familiar with this, but just in case you're not, let me just give it a quick rundown. So the x-axis here is the duration cycles. It's logarithmic, 10 to the power 0, 10 to the power 1, 10 to the power 2, so 0, 10, 100, 1,000. And then this is the magnitude along the y scale here. The idea, these are what are referred to as compliance curves, and this is the ITIC curve. Prior to this, we had the Savima curve. The ITIC was essentially an update of the Savima curve. There's also a SIMIA 47 curve. And you can also develop compliance curves that are specific to a piece of hardware, your facility. And PQView does support bringing in other compliance curves other than just the standard ones. So if you wanted to plot events on your own compliance curve, you could. So the idea of this is that anything inside of this envelope should not cause problems for equipment. So the events that are down here, and if we had any dots up here, would likely cause, because of their duration or due to how deep they got, they would cause equipment to trip offline. Now, this is keyed towards switch mode power supplies. And this is, again, an interactive chart. You can actually click on these dots, all have waveforms corresponded to them. So, click on them and see what the event is, what the event was underneath it. We do also, of course, support viewing data logs, whether you call them value logs, interval data, all the same thing, but we call them data logs inside of PQView. Looking at this is the RMS voltage over the time frame. This is our static chart here, and then this is our interactive one down below. So you can zoom in on it, and you can also turn channels off and on, and export it, do all that good stuff. Or we also have our analysis tools for data logs as well. So here showing the profile chart above a histogram chart. So, of course, the histogram gives you some statistical analysis about what the value that you're looking at, in this case, voltage, was at over the time frame statistically. And then the profile chart here is showing the same thing, just over an hour bends. So from 0 to 1, midnight to 1 o'clock in the morning, 1 o'clock in the morning to 2, that type of thing. This is difference in percentage between two channels. I'm just showing it between two current channels. Wanted to highlight this because this is actually one of our new derived charts, and this derived chart was actually created for one of our customers. What the customer was doing is they were testing sensors, but they were measuring the same thing with the two sensors, so they wanted to be able to tell the difference between the values that the two sensors were capturing. And prior to us building this into PQView, they'd have export it into Excel and do all sorts of manipulation on it, and it was kind of prone to error and all that. And when we built this for them, they got really excited because it's essentially turned something that used to take hours into seconds. So nice little feature there. Just kind of throwing out there, if you do see ways that we can improve on PQView, we are always welcome for feature suggestions. This is showing more analysis. This is showing over a 24-hour period, 12 a.m. to 12 a.m. day to day, showing what the value is. So again, we're showing voltage. So what the voltage was like. This would maybe help you find trends, like if something's happening right at 6 o'clock every day, or something's happening right at 9 o'clock in the morning. It'll help you notice those types of trends. Same thing here, showing crosstab by week. So if something was happening on a weekly basis, every Wednesday, every Thursday, that type of thing, you'd start to become evident in this type of plot. If you have multiple values, different types of values, so here I'm showing current and voltage. The voltage is kind of lost in the current chart here due to the scale, primarily because the voltage is in percentage, whereas the current is in amps. So, the voltage is for the most part right around 100 there. So by doing this, we can do stack charts and stuff like that for analysis purposes. So just to review the benefits of PQView, would bring in all the data. We're fairly device agnostic. Regardless of the data source, we can usually bring it in. Once you have that data in PQView, we have what we consider best-in-class data analysis tools in order to perform your analysis against that data that you have. You can quickly get your summary of your system performance to identify problematic locations. Whether, again, upstream or downstream, it will usually greatly differentiate your approach to what your next steps would be. At a utility, whether it's on the transmission system or the distribution system, can a lot of times determine which department is going to be doing analysis. The fact that we're extensible via SDKs, I can't underscore that enough, that is, once you start thinking about what you can do with the data, especially if you have some developers available, We can do some really neat stuff with PQView. Being able to benchmark your performance, identify if you're a facility manager and your supervisor comes up to you and says, "Hey, how's we been doing this year versus last year?" If you had PQView, you'd be able to answer that question. That's probably the type of question that your management might expect you to be able to ask. And then again, so that really what we're doing with PQView is trying to turn data into information. And one of the ways we're doing that is bringing in all that data together so that you can view it all at once and massage it, view it geographically, view it temporally, all these different ways of looking at it in order to try and surface the information that's in that data. All right, so we don't have a lot of time here, so we're probably not going to do our live demo. Actually, I'll just pull it up. Okay. This is our external demo portal, pqweb4.electrotek.com. If anyone is interested, you can either create a ticket at support.electrotek.com or send an email to support@electrotek.com if you want to get access to that. Of course, all of that, we definitely want you to visit our website at electrotek.com. Up here, we have links to our support portal up here, contact information. You can also request the login via there. If you click on the login here, that will get you, if you have purchased stuff from us, this is where you would go to download that software. But, and of course, all of our social media links are up here as well. We spent a lot of time and effort on trying to build this new website. We think it does a pretty great job of surfacing a lot of good information. So definitely recommend going and checking that out. If you're interested in kind of poking around on this PQWeb4 system, you can come in here and just pull up events. All right, you can view the event, you can zoom in on it, and then you can do derived charts. So yeah, that's our that's the demo. Sorry, it wasn't a bit more comprehensive, but we kind of ran out of time here. So we do have some questions though. So we have a question about where in situations where a protocol is not supported. In those situations, it really depends on what protocol you're referring to. I would recommend again reaching out to our folks, either our support portal or via that contact form for questions like that, so we can get into specifics. We have a question about analyzing the data about the incipient failure slide. That was provided by a customer. I'm not sure if I can actually speak to it. For fault location, we're analyzing the waveform and we're calculating the fault reactance. So we're calculating a reactance value using positive, I want to say it's positive sequence reactance, not traveling wave, no. We're using positive sequence reactance to fault. And we actually have different ways of calculating, but it is all, sorry, my audio went out again. We have notes, a loop reactance or just reactance to fault. So those are the different, it's all reactance values that we're calculating there. Okay.